Okay, so now before we put in the radius here and take this diameter down in the middle, in between that, where that octagon is going to go and the end here, we're going to take this and we're going to flip it around. Reason being is, right now I have a nice place to chuck on this here. Okay, so we're going to flip this around and we're going to indicate it in. Okay, now if you have serrated jaws, you can put some packing in there to not make any marks on your finished surfaces. So that's my high. I'll loosen my low. Tighten the high. Loosen low. Tighten high. Loosen low. Tighten high. Okay, so now we're getting pretty close. Alright, let me see. Let's tighten everything around. Okay, we're within like half a thousandth there. What I'm going to do real quick just to check myself is I'm going to get a dial test indicator and we're going to run it on this inside face here and make sure that we're not tilted out this way. Okay, so now we are going to take it down to this length right here, this diameter right here, which is going to be 465 thousandths. So we're going to go ahead and take that down right now. Yep. Alright. I'm at 475 thousandths, so I need to take 10 off. I have my indicator mounted on my carriage there. So we're going to come in, I'm going to change my feed to feed out. Since I'm running high-speed steel, I can oil this up a little bit. So I'm going to come into the middle, unlock my carriage. I'm going to move the carriage in 10 thousandths. Engage my feeds. Come into the center, and then we'll just feed out. you're just going to confirm our measurement. 465 on the money. So now I can move my carriage out of the way. All we're going to do is take a file and we're going to very gently knock that edge off. We don't want to round it over or anything, we just want to get rid of a burr. That's all that requires. And then we'll just get paper towels here. And just real quick. Finish on this side doesn't really matter. I'm just getting any high spots off of there from the tool skipping, because obviously because of the diameter change as you have a facing cut, the surface feet per minute across that tool changes and impacts that surface finish. So and that's perfect there. Okay, so now what we want to do is we are going to drill right through this. We have to make sure that we have a drill that's long enough. So let me get my drill bits and my reamers all set, and then we can drill the center hole in this sucker. Okay, so we're going to center drill this first, and then we're going to go through with a 31/64 drill bit. Okay, you want to make sure that you have one that's long enough that'll go through the entire piece. And then after we get this in there, we're going to go in with our 501 thousandths oversized reamer. So let's get a center drill in here. Okay, so now we're going to ream that. I want to slow my machine down. So what I'm going to do is we're going to slip this into back gear here. this up nice, and in we go. Okay, reamed all the way through now. Okay, so now what we're going to do is we're going to counterbore this to fit our bearing. So it's going to be a diameter of 937 thousandths by a depth of 250 thousandths. Double check your bearings and make sure they match that. So what we're going to do is we're going to come in here. We know this is 501 thousandths. Okay, I'm touching right there. We're going to zero our dial. All I'm going to do right now is I'm going to give myself a starting point. See where we're at. Nine, 10. That should be it right there. Alright, that's the fit that I want on that washer. That little first test cut, I went a little bit too proud, but that shouldn't hurt anything. that should pretty much be it right there. Just make sure. $3,000 shy. Let me go just a hair more. Alright, so now all we have to do is take this out, and we are going to put in that little diameter that's going to be in between that front face and our nut. So it's going right here. We're going to put this diameter in these two radiuses. Okay, so now you can see how we're holding this here. And what we're going to do is we're going to indicate against this face here and this outside face here. Alright, so I just swung my compound around, so that way there I can make a 60-degree angle on the inside of this to allow me to use my center in here. So we're just going to put a little 60-degree angle in here. It's going to give you a spot to, doesn't have to be huge, just a quick little 60-degree chamfer in there. Alright, so you can see I have a nice spot for my live center to ride in there. Okay, so now our goal is to take out the inside here and bring this down to the 1-inch 12 thousandths. So I have the 300 thousandths marked out. That's going to be our basically our nut, our octagon shape, and we're going to plow out the middle of it. Now I'm going to leave space here, and I'm going to leave space on the inside here, because we're going to come in with a form tool afterwards, and we're going to put a radius in there. So I'm just going to do this by eye. Okay, I'm going to change out this bit for a right-hand tool bit, and we're going to come right up to the edge here. Okay, so we have a radius tool in here, and we're going to put our radius here, in here. Now I have to have it sticking out far to be able to clear this, so it's probably going to chatter. You know, I have no way around that, so let's see what we can do. machine down. Alright, all I'm going to do here is just come in, myself a little bit of a, just nick that edge. Just like that. Okay, so I could take a piece of sandcloth and just blend those in and we're good to go. So let me go ahead and do that and then we'll head on over to the mill. Okay, so what we have here is a square collet block. This acts as being an ER collet block. And what we're going to do is we're going to touch off and we're going to start cutting our Octagon. Now, since I don't have an octagonal collet block, we're going to do 4 flats and then we're going to index this 45 degrees and then do 4 flats. Now, I use one of those little online Octagon calculators that tells me what the depth I need to be, so I need to go down 51 thousandths for this outside diameter to make all those facets fit. So what we're going to do is we are going to turn our machine on and we're going to crank our table up just until we touch. Okay, we're going to call that 0. And we're going to move our table up 51 thousandths. Okay, there's one flat. And there's 4. Okay, so now what we're going to do is we have our little protractor here set at 45 degrees. We're going to leave the collet block in the vise there. Okay. Then I gotta move this out of the way just to get the clearance. We are gonna index that until that touches there. And then we're going to tighten down our collet. Okay. We moved a little bit, so I can just readjust it, not a big thing. Alright, I know that angle was probably kind of terrible, but what we did is we cut our first 4 flats, and then we loosened the part in the collet and indexed ourselves at 45 degrees off of one of the flats that we made without taking that collet block out of the vise. And that is going to give us our other 4 flats. So you can see we intersected perfectly there. Alrighty, so now we're indexed to the other flat, where we want the other flat to be. So we'll just come back here, line this sucker back up. And you can see we connected perfectly. Okay, now for the moment of truth. Took out the old screw. You can see I just deburred everything. You can see the little facets there. They're pretty even. One is slightly smaller, these guys here, but not by much. So as you can see, I didn't even test fit any of that. I did it perfectly by using the thread wires, no rock. You go in there nice, we tighten up, and we can give it a little snug. And we're in, and I didn't even plan this. That flat ends up perfectly flat on the top. So now, what we need to do is start working on modifying our freed screw, which will be a video for next week.